Hello, welcome to your Finite Math 5.3 lesson on present value annuity problems. So an annuity is a series of payments made at equal time intervals, and P is the present value of an annuity. It is the value that you would need to pay in one lump sum right now in order to equal all these future payments that you're going to pay. So, for example, suppose that at the end of each quarter for the next 10 years, $100 is deposited in an account paying 7.15% APR. This is an example of an ordinary annuity. Every quarter comes along, at the end, you deposit $100. Okay, the present value of that annuity is the amount that you would need to invest in one lump sum today and get 7.15% APR compounded every quarter for 10 years to end up with the same amount of money. Okay, so here's our nifty formula for that. P is the present value, the value you need to pay right now. R is the amount that you would pay for each of the compounding periods, and I is the interest rate per period, or R over M, and N is the number of periods, or M times T. Okay, so Mr. Breyer and Ms. Gonzalez are both graduates of the Brisbane Institute of Technology. They both agree to contribute to the endowment fund of BIT. Mr. Breyer says that he will give $500 at the end of each year for 9 years. So 9 times 500, he's going to donate $4,500, but spread out over 9 years. Ms. Gonzalez prefers to give a lump sum today. What will she need to do? Will she need to do $4,500 today? Could she do less? Should she do more? What should she do? So what lump sum can she give that will equal the present value of Mr. Breyer's annual gifts if the endowment fund earns 7.5% compounded annually? Okay, so the R value is 500. So we're going to plug that in for R because that's how much he's paying each year. He is making these payments annually, and the endowment fund is compounded annually, so M is 1. Little r, the interest rate, is 0.075, so 0.075 divided by 1 is 0.075. N is M times T, so everything's compounded once a year, times 9 years, so you have 9. So we're going to end up with 500 times 1 minus 1.075 to the negative 9 power divided by 0.075, and we get $3,189.44. So since her one lump payment will be earning 7.5% interest all 9 years, her $3,189.44 will equal Mr. Breyer's $4,500 plus the interest he's earned on the $500 each year that he has contributed that. So she actually will have less out of pocket because she's doing it earlier. Okay, a car costs $35,000. After a down payment of $8,000, the balance will be paid off in 3 years in equal payments each month at 6% interest APR on the unpaid balance. Find the amount of each payment. So here we'll know the present value of the annuity, and what we'll be doing is we'll figure out what monthly payments would be that will equal the same amount. Okay, so we've got P equals 35,000 minus 8,000, which is 27,000, because that's the amount actually being borrowed. So 27,000 equals the payment that's going to be made times 1 minus, now we've got to figure out what I is. It's that 6% APR divided by 12, because everything's been compounded monthly and we're making monthly payments. So 0.06 divided by 12 is 0.005. And then N equals M times T. So 12 times 3, so 36. So here we've got our unknown payment amount, which we want to figure out, times 1 minus 1.005 to the negative 36 power over 0.005. Okay, so we've got R times something really ugly, but this something really ugly right here is just simply a number, so we divide both sides by that number, and we get R equals $821.39. Okay. Amortization. A loan is amortized if both principal and interest are paid by a sequence of equal periodic payments. In the previous example, a loan of $27,000 at 6% interest compounded monthly could be amortized by paying $821.39 per month for 36 months. Another way to figure that out is by using this cool little formula, which is just a manipulation of the previous formula. So we get payment, R, is equal to PI divided by 1 minus 1 plus I to the negative N. Okay. A monthly mortgage payment consists of an amount paid toward the principal and the interest on a loan. The Wimberleys have taken a 30-year mortgage loan for $150,000 with an interest rate of 6% APR. What will the monthly payments for the principal and interest be? And then we're going to figure out how much will they pay in interest over the life of the loan. I think you will be shocked. Okay, so we need to know P. So P is the amount being borrowed, so $150,000. I is R over M, so our annual percentage rate is 6%, so 0.06. These are monthly payments, and so M is 12, so 0.06 divided by 12 is 0.005. N is equal to M times T, so 12 times 30, so that's 360 compounds of the interest. So we plug in our values. So we have 150,000 times 0.005 over 1 minus 1.005 to the negative 360, and we get $899.33. Sounds great. Okay, borrow $150,000, pay less than $1,000 a month. That's awesome. So $899.33. Let's see how much they're going to be paying over a lifetime. So the total amount paid is going to be the number of payments, so 360 times R. So 360 times $899.33 is $323,759. Now, the total paid is principal plus interest. So what was the principal? What was the original amount? $150,000. So $323,759 equals $150,000 plus I. Subtract $150,000, you get $173,759. So the Wimberleys are actually going to pay more in interest than they borrowed in principal, which is what happens with 30-year mortgage loans a great deal of the time. Okay, guys, go ahead and do your problems to try on your own. Make sure you've got them done and then bring them to class. And thank you again for taking great notes and paying attention. I will see you in class, and I hope you have a great day.